The story begins with a simple question that has followed humanity for as long as we have looked up at the night sky. How far back can we actually see? Every telescope ever built has been, in a sense, a time machine, capturing light that began its journey long before Earth looked the way it does today, long before cities, before civilizations, before life as we know it. Yet even with that perspective, there's always been a horizon, a moment beyond which the universe seemed out of reach. Today that horizon has shifted again, and at the center of this shift is a faint, almost invisible speck of light, a galaxy so distant that what we see is not just far away in space, but incredibly early in time, appearing as it existed when the universe itself was still in its infancy, only a small fraction of its current age. This is not just another discovery to add to a long list of cosmic milestones. It is a window into an era that until recently lived mostly in theory, an era when the first islands of stars were beginning to ignite in a universe that had only just emerged from darkness. To understand why this discovery matters, it helps to imagine the early universe not as the vast, structured cosmos we see today, but as something far simpler and far more chaotic, a place where matter had only recently begun gathering into the first gravitational pockets, where the first stars were switching on and filling space with light for the first time. For decades, astronomers have tried to piece together what this period looked like, using simulations, indirect evidence, and progressively more powerful observatories. Yet direct observations remain scarce because galaxies from that era are extraordinarily faint and extremely distant. This galaxy changes that landscape because it does not just exist at the edge of what we can see, it pushes that edge further back, offering a rare and tangible glimpse of how quickly the universe was able to build complex structures after its beginning. The discovery itself unfolded in a way that mirrors many scientific breakthroughs, beginning not with certainty, but with curiosity and skepticism. Researchers, scanning a well-studied region of the sky, noticed a tiny, unusually red point of light, the kind of object that often signals great distance because the expansion of the universe stretches its light into longer wavelengths. At first, it was simply a candidate, one of many intriguing possibilities that might turn out to be something else upon closer inspection, perhaps a closer galaxy obscured by dust or an observational artifact. For months, teams examined the data, debated interpretations, and tested alternative explanations, because extraordinary distances require extraordinary evidence. The turning point came when detailed observations revealed the unmistakable signature that marks truly ancient light, confirming that this faint glow was indeed arriving from a time when the universe was only a few 100 million years old, making this galaxy the most distant confirmed example of its kind ever observed. What makes this object especially compelling is not only its distance, but its character, because it appears to challenge expectations about how galaxies should behave so early in cosmic history. In simple terms, it seems too mature for its age, too bright, too chemically evolved, as though it condensed and grew at a pace that outstrips what many models predicted. Astronomers studying its light found signs that multiple generations of stars may have already lived and died within it, enriching its environment with elements that normally take time to accumulate. This hints at a universe that may have formed stars more rapidly or more efficiently than previously thought, suggesting that the first chapters of cosmic evolution were more dynamic and perhaps more turbulent than our current narrative describes. Brightness is another piece of the puzzle, because this galaxy shines with an intensity that seems disproportionate to its compact size, almost as if a vast metropolis of stars were compressed into a surprisingly small region. For viewers, the analogy is simple. Imagine seeing the glow of an entire city condensed into the footprint of a small town. This raises questions about how densely stars could form in the early universe, and whether the processes that governed early galaxy growth were fundamentally different from those shaping galaxies later on. The answers are not yet definitive, but the existence of such an object forces scientists to revisit assumptions, refine models, and explore new possibilities, which is precisely how scientific progress often unfolds, not by discarding established ideas overnight, but by adjusting them to accommodate new evidence. Another layer of fascination comes from the realization that when we observe this galaxy, we are not seeing it as it is today, but as it was billions of years ago, because the light reaching us began its journey long before our planet even formed. In the present day, that galaxy would be far beyond the distance implied by the time its light traveled, carried further away by the ongoing expansion of the universe. This dual perspective, seeing an object both as it was and knowing it now exists at an even greater separation, captures the unique way astronomy blends space and time into a single narrative, turning observation into a form of cosmic archaeology where every photon is a fragment of history. Beyond the technical intrigue, discoveries like this resonate on a more human level, because they reshape our sense of scale and origin. Each time we push deeper into the universe's past, we refine our understanding of how everything we know came to be, from the formation of stars and galaxies to the eventual emergence of planetary systems and, ultimately, life. This galaxy is not directly connected to our own cosmic neighborhood, yet it represents a step in the chain of events that made our existence possible, reminding us that the story of the universe is not static, but continuously unfolding as our tools and insights improve. Equally important is what this discovery says about the capabilities of modern observatories, which are designed not merely to take sharper pictures, but to capture light across a range of wavelengths that reveal hidden details about distant objects. The ability to analyze the faint glow from such remote epochs demonstrates how far observational astronomy has progressed, transforming what once seemed unreachable into measurable reality. Each new detection at these distances expands the sample of early galaxies, allowing researchers to move from isolated discoveries to broader patterns, which will eventually clarify whether objects like this one are rare exceptions or representatives of a more common early population. As the scientific community continues to study this distant object, the focus will likely shift from confirmation to interpretation, exploring questions about how its stars formed so quickly, how its structure assembled, and how it fits into the larger tapestry of early cosmic evolution. These investigations will not only refine our understanding of this single object, but also help establish a clearer timeline for how the universe transitioned from darkness to the richly structured cosmos we observe today. In that sense, this galaxy is less a final answer and more a starting point, a beacon that guides future observations and inspires new theoretical work. For audiences watching this story unfold, the significance lies not just in the numbers or records, but in the perspective it offers. It demonstrates how science advances through careful observation, debate, and verification, turning faint signals into meaningful knowledge, and it highlights the collaborative nature of discovery, where teams around the world contribute pieces to a puzzle that spans billions of years. Most importantly, it reinforces the idea that the universe still holds many surprises, and that each breakthrough is both a conclusion and an invitation to look further. In the end, this tiny, distant galaxy stands as a reminder that exploration is not limited to distant planets or future missions. It is happening right now every time we capture ancient light and decode its message. This faint point in the sky, barely visible even with our most powerful instruments, expands the boundary of the known universe and deepens the narrative of cosmic history, illustrating how a single glimmer can transform our understanding of time, space, and the processes that shaped everything around us. And as we continue to refine our tools and extend our reach, the horizon will move again, revealing new chapters of a story that is far older and far larger than we once imagined, yet one that we are only beginning to read.